fundamental principle of counting. The fundamental principle of counting is, so you can say if you have m ways of doing one task, okay, m ways of doing one task and n ways of doing another task. I'll explain what this means in a second. N ways of doing another task, then you have m multiplied by n ways of doing both tasks. Now let me explain what that means. Okay, it's like the example I gave you earlier. If you have 3 shirts and you have 4 trousers, okay, the number of different combinations you can make of shirts and trousers is 12. Remember, most of you gave an example like that? It's the very first thing in your book under probability. It's called the fundamental principle of counting, and that's the definition of it. But you get full marks for using letters, so you could say if I have A ways of doing one task, B ways of doing another task, then the number of ways I can complete both tasks together is A multiplied by B. Or in the question I put on the board, M by N. Or on the example I gave, 3 shorts by 4 trousers gives you 12 different.
How do you use numbers?
It doesn't quite get you the full marks of the definition. You got high marks, but not the full marks. You didn't know the definition, but you all gave it a go, which means you got 7 or 8 out of 10. Okay.
So what does that say?
If you have m ways of doing one task and n ways of doing another task, then you have m multiplied by n ways of doing both tasks. Okay. Next question. How many different ways are there of arranging 5 distinct objects in a row? Now, 5 distinct objects in a row, lads. You remember here. I have a choice of 5 objects. If 5 objects I have a choice of 5 objects to go in the first place. Once that's done, how many objects are left to choose from?
4.
You choose one of them, then there's 3 left for the third place, 2 and 1.
You see 5 exclamation mark.
Most of you guys read this as 5 factorial, because that's what this is. So you go to your calculator, and your calculator has you press 5, and you're looking for an exclamation mark. It's the yellow button above the inverse. So shift, inverse, 5 factorial. What 5 factorial stands for is 5 by 4 by 3 by 2 by 1. And what you get there is 120. Is everybody right with 120?
Yeah.
Okay, most people got 120 out for that question there. Now, next question. This one was tough. Okay? Peter is arranging the bookshelves. He has 5 novels and 3 poetry books. He wants to keep the 5 novels together and the 3 poetry books together. How many different ways can you arrange the books? Now, a lot of people made a really good go at this, but you're just lacking one little part at the end that tripped you over. So, for the time being, I'm going to imagine that the poetry section's to the left and the novel selection is to the right. So the novel has 5 shelves and the poetry has 3 shelves. Okay, in your poetry one, you have 3 possible books that could go into the first slot. Once you use one of them up, there's 2 left, and there's 1 going to go in last. If you imagine there is 6 different combinations this can be done. So I'm just going to write the combinations out. Let's say the first book is called A, the second book is called B, and the third book is called C. You have all the different combinations you can arrange them as. So I could do this. I could do ACB. I could then go BAC, BCA. Then I can do CAB, or I can do CBA. You can see all 6 different combinations, can't you? So this here represents 3 multiplied by 2. This represents 6 combinations in total. The next one, if you want, I can call it, we can call them books D, E, F, G and H. Now the problem is, it's not as easy to do as ABC, is it? Because ABC, there's only 6 different combinations. With 5 different objects, there's going to be so many more combinations. So it's 5 by 4 by 3 by 2 by 1. And as somebody already stated, that's 5 factorial, which is 120 different combinations. There is no chance I'm writing out 120 different combinations here today. Okay? Now let me explain let me explain the final point. The final point is, this comes back to your fundamental fundamental principle of counting. You have 6 ways of doing the poetry books, and you have 120 different ways of doing the novels. How many combinations are there in total?
720.
Now, 720 is half the answer. Now let me explain why. We're only considering the poetry section in front of the novel section. We also have to consider that the novel section can occur in front of the poetry section. Therefore, the answer we came up with needs to be multiplied by 2 to become 1,440. How many people got that answer out? So, just question 2 states, Katie tossed the coin 200 times and threw 109 heads. Joe tossed the same coin 400 times and threw 238 heads. Lucy tossed the same coin 500 times and threw 291 heads. Katie, Joe and Lucy now think the coin may be biased. Give one reason why you think the coin may be biased. Okay, so the coin may be biased because of the following reasons. The coin is considered biased. I realised my writing wasn't great. So, because the number of heads that occurs is always more than 50%. Would everybody agree with that? Yeah. Over half of them are always more than 50. Okay, so it's interesting. So there you go there. So that's your answer there. Okay. So that there. Are we happy enough with that? Okay. Lucy uses all, keyword, all of the above data. What does all of the above data mean? How many times did we throw it then? We threw it 200, the next person threw it 400, and the third person threw it? That is, okay. You add them together and you get 1,100. Okay, that's how many times we threw the coin. How many times did we land a head? 109 plus 291 plus 238.
638.
638. Finally, what is that as a decimal?
0.58.
So, what percentage of the time are we talking about landing heads? 58% of the time. Now, if you only threw that 20 times, yeah, and you got 58%, that's not such a big deal because you threw it a small amount of times. When you throw it 1,100 times and it's 8% out, you have a feeling it must be slightly biased. Okay, now there is a chance it isn't biased, but because you threw it so many times, it should level out towards 50-50, and it hasn't. So it means it's more than likely biased. Now, the next thing is the next thing is the multiplication rule. Shh, lads, excuse me. Let me tell you something here, okay? If we had a coin, are you listening? If we had a coin, most coins are 50-50. Would you agree with that?
Yeah.
Now, if I ask you what's the probability of getting one head, what is that? A head. Huh?
50%.
Or a half, yeah? So, probability of getting one head is a half. What's the probability of getting one head and then tossing the coin a second time and getting another head? It can't be a half plus a half. Because a half plus a half is 100%, is 1. So, it's a half multiplied by a half, which gets you a quarter. If I wanted 3 tails, lads, what would that be then? An 8. It's a half multiplied by a half multiplied by another half. Now, using this logic here, using this particular coin, the odds on us getting a half are 0.58. Oh, sorry. The odds on us getting a head is 0.58. The odds on us getting a tail, 0.42. If one of them is 58%, the other one must be 42%, because there's only 2 outcomes. Now, how do we get 3 heads, guys? Is that what you want? 3 heads. 0.58 multiplied by 0.58 for the second head and 0.58 for the third head. It always has to be between 0 and 1. If you've gone over 1, you've done it wrong. So what do we get when you multiply 0.58 by itself 3 times? Somebody has it. I know somebody in the class did it.
1.74.
No, you added them.
0.195.
1.74.
You added them. 0.195. You can't. It can't be over 1, Sean, because if it's over 1, it's over 100%. And you can only be 100% sure that something happens. You can't be.
It was 51% and 58, but so it's twice.
If it was 51%.
So 58.
No, that'd be close enough in my opinion. It's very abstract as an answer.
You can't say it's close enough if she's through 1100 times.
You could argue that, but I think 1100 times is enough to be 8% out is a significant number. Guys, next one is 2 tails. 2 tails is 0.42 followed by another 0.42, and what do you get for that?
0.176.
0.176. Now guys, read the language. Joe agrees that Lucy's estimate is a probability of throwing a head with the coin. He claims that the probability of throwing 3 successive heads, which is this number here, is smaller than this number here. Is his assumption true? Is his claim true? No, it's not. Reason being, probability of 3 heads is greater than the probability of 2 tails. Okay? So therefore, that's the problem there. Is that alright? Okay. Now, what we have next is question 3. Now, expecting most people to clean up here, okay? A car is selected at random. What's the probability that the car is black? Mick, the car is black?
Okay.
What's the probability?
What was question 3?
Question 3, yes.
5 out of 24.
5 out of 24. 5 out of 24 doesn't break down anymore in your calculator. What about black or red? How many black or red cars are there? Sean, black or red? 5 plus 9
14.
out of 24. Now that won't get you full marks. Why won't that get you full marks? Put it away.
Which?
Yeah, the phone.
I should have the calculator on.
Alright. You should have your proper calculator though.
I don't have one.
7 out of 12.
Yeah.
Okay? Now, a car is selected at random, then a second car is selected at random. Remember, you're not going to add them, you're going to multiply. Okay? So, what's the probability of your first car being silver? 10 over 24. The next probability is out of 23. Because you want silver followed by black. SB. How many black cars is there? 5 out of 23. When you multiply them by each other, what you get?
0.09.
0.09 in the calculator. Is that okay? Or you can leave it in fraction mode if you want. What's it in fraction mode, lads? 25 over 27? 6. Now guys, Paddy, read the language of the next question. One of the selected cars is red and the other is black. What does that mean? One is red, one is black. What 2 combinations qualify?
One is red.
Red, black, or black, red. Both combinations qualify for one being black and one being red. So, how many red cars do we have? We'll do red, black first. How many red cars do we have? 9 out of 24. We're going to pick a second car out of 23. How many black cars do we have? 5. What's the answer for that?
You just multiply.
Just in fraction mode would be grand.
15 over 184.
13 over
15 over 184.
184.
15 over.
15 over 184. Paddy, what's wrong?
Question on the marking of my question.
Mark it with an asterisk and come to me at the end of class. Okay. Now guys, next one we're doing is black red. How'd you do black red? Black red is you're choosing a black first, so it's 5 out of 24. Followed by a red? 9 out of 23. Multiply it and you're going to get exactly the same thing. Now, you have to add both results together. The word or in probability. I can have red, black, or black, red. That means addition. And means multiply, or means plus. So you're going to get 15 over 184 plus 15 over 184. And what you get when you add the two of them together? 15 over 184 plus 15 over 184. Anybody? Nobody yet? No?
15 over 92.
15 over 92? Yes, it is. Okay, 15 over 92. So the answer is 15 over 92 for that one. Okay. Now, 3 of the black cars, 2 of the red cars, and 4 of the silver cars have diesel engines. 1 car from the garage is again selected at random. Find the probability that it is a red or a diesel car. Now here's the problem, guys, okay? How many red cars do we have? Red cars are? 9. So I'm going to do it this way. Red and diesel. How many cars are both diesel and red? 2 of the cars are diesel and red. How many red cars do we have in total? We have 9 in total, don't we? But 2 of them are diesel. So 7 are red only. 2 of them are red and diesel. How many diesel cars do we have? In total we have how many diesel cars? 3, 5, 9. We have 9 diesel cars. That means we therefore have 7 diesel cars that aren't red. Now, look at this here, okay? We have 24 cars, right? 24 cars, correct?
Yeah.
Now, what we have here is 7 reds. It can be red or diesel. 7 reds qualify. The 2 red or diesels, red and diesels qualify, and the 7 diesel only qualify. So all 16 cars qualify, resulting in an answer of 2 over 3. Who got that one? I think Paddy, you got that one, did you?
Yeah.
Lads, because these events, because a car can be both red, it can be red and diesel, these events are not mutually exclusive. Mutually exclusive means you can't be both. Okay? So remember when we said, can a card be a club and a spade at the same time? The answer is no, you can't pull a card that's a club and a spade. However, can we pull a card that's a club and a queen at the same time? We can. Therefore, that event is not mutually exclusive. Because we can have a card that's a diesel and red coloured, that means that these events can occur at the same time, hence they're not mutually exclusive. Keep an eye on that word, it will pop up again. Now, number 4, this one here. Now this is an interesting one. This one you found very hard. It would have came from junior cert sets. Remember sets in junior cert? Shh. Okay lads, look at this one. Okay, in a school, 600 students, 200 play musical instruments, 80 sing at the choir. The probability that student neither plays a musical instrument nor sings is 7 out of 20. Now let me explain the most common mistake everybody made. Everybody put 200 in here and you put 80 in here. Do you know what that isn't including? It doesn't include people who sing and are in the choir, okay, or play musical instruments. So an example would be, just as an example, imagine 50 people both sing and play music. You have to take this 50 away from the 200, so that becomes 150, and you take that 50 away from the 80, so it becomes 30. Therefore, when you look at your circle, there's still 200 people that play music. It's 150 plus 50, and there's still 80 people that sing in the choir. You happy enough with that? Mm-hmm. Now, here's our problem with this question, okay? Problem starts off with is basically we have 7/12 of the entire population play nothing. What's 7/12 multiplied by 600? 350. 350 people play nothing. Do you got it? That means that there has to be, within the region here, there must be 250 people in total between these 3 regions. Okay? Now, the problem with entering the 200 and the 80 straight away is that, am I allowed 250 people in there? You're saying I have 280. What's the reason why I have too many people? Sorry? It didn't use the middle. I don't know what the middle is, so I'm going to call it a letter called x. I'm going to take x away from 200 in the same way I took the 50 away from it earlier on, and I'm going to do 80 minus x. Now, lads, what do I know happens when I add every area together? What must happen? How many people do I have in total?
600.
So, 200 minus x is region 1, region 2 is x, region 3 is 80 minus x, and region 4 is the outside one. All of this must add up to 600. Therefore, add your numbers together. 280 plus 350. Anybody? 280 plus 350? 630. Minus x plus x cancels. And minus x here. Now, 630 minus x. What's x going to be? 30. Because 630 minus 30 is 600. This means that your middle is worth 30. So look at this. Change your middle into 30. What's 200 minus x now? 170. And what's 80 minus x? 50. And there you go there. Okay? Now, find the probability that the student sings in the choir and plays a musical instrument. How many students both play the sing in the choir and play a musical instrument? 30 out of 600. And what does that come to, Paddy?
120.
1 over 20. Okay. Now, the next question, we're looking at this here, is I'm just going to cut there, bring it back over, sorry about that.
So how many marks is there on for
5 markers for each one.
5 marks?
Yeah, because it has to add up to 25. So, if I put this here now, instead, it goes, find the probability that a student does not sing. What happens if he doesn't sing? All the students that don't sing, which one's singing again? Is it C or M? C. So what I'm going to do is I'm going to circle C. I want everything that's not inside of C. What's not inside of C is the 170 and the 350. So add them together and I get 520 out of 600 is what then? 13 over 15. Okay. Now next one. Listening. Find the probability that a student plays a musical instrument only. Musical instrument only, anybody? Why is it not 200? The 30 in the middle, while they play a musical instrument, they also happen to sing, which is not acceptable. Okay, Paddy? So it's the 170 only. So it's going to be 170 divided by 600, which gets us what, guys? 17 over 60. Okay, that's grand. Now, the next, yes, Sean.
How come it's on 200?
Once again, every section going for 5. Each question goes for 5. Unfortunately, nothing for the diagram itself. Now, in the first one, we have red, 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 and we have 1 blue. In the second one, we have 1 red, and we have 3 blues. Now, this is an AND question, right? There's only certain combinations you can get. So you're going to pull a cone out of one box and a cone out of the other box. Here are your following combinations. You can have a red followed by another red. You can have a red followed by a blue. You can have a blue followed by a red. Or you can have a blue followed by a blue. Would everybody agree that's all 4 outcomes?
First one.
No, I haven't answered any questions yet. I'm just going through the general gist of how this game works. Okay? Next thing. What we're going to do next, guys, is that we're going to both are red. Your odds of getting your first red are 4 in 5. Would you agree with that? Your first red is 4 in 5. What about your second red? 1 in 4. Multiply them. Don't add them. It's and. You want a red and another red. And your answer is 1/5. Part 2. Both are blue. Blue followed by another blue. So what's your odds of getting a blue in the first game? And you're also getting blue in the second one.
Yeah.
And your answer will be 3 in 20. Next one. The first is red, the second is blue. So red followed by blue. Red in the first game is going to get you what, guys? Red in the first game? 4 out of 5. Blue in the second game? 20 seconds. I'll finish this off, then I'll let you have a break.
3 out of 4.
3 out of 4. And what's the answer going to be?
You multiply.
And you get 3 out of 5. Shh. Excuse me. Blue, red. Mick, blue, red. What's the answer for blue, red? Blue in the first game, red in the second game? Just look at the board. You better figure it out.
Yeah.
First game, how many blues do we have?
4.
1 and 5. This is the first game here.
How many blue? Oh yeah,
1 and 5. Shh. How many blues in the second game? How many reds in the second game?
1.
In 4. Shh. We're just going to get me 1 out of 20. Finally, you want blue or red in any order. What does blue or red in any order mean? No. Dennis, what does blue or red mean in any order? If I want 1 blue and 1 red, how many different ways can this happen?
1, sorry, it's more than 4.
It can happen these 2 ways. You can have a red followed by a blue,
Switch it around, but.
or a blue followed by a red. You're going to add them together. Paddy, red blue is 3/5. Blue red is 1/20. When you add them together, you're going to get 13 over 20. Okay, that's